You buy a washing machine for $1,100 because the salesperson explains it uses less water, cleans better, and is built to last. It has a digital display, 12 wash cycles, a steam setting, and a Wi-Fi connection you never use. 4 years and 3 months later, it stops mid-cycle with a drum full of wet clothes and an error code on the panel. The technician comes out, runs a diagnostic, and quotes $420 to replace the main control board. The part is on back order, 6 weeks, because the manufacturer revised the board design and the previous version is no longer in production. Your machine is 4 years old. The warranty expired at year 1. That control board did not fail because you were unlucky. It failed because it was a consumer electronics component placed inside an industrial appliance in an environment of steam, vibration, and thermal cycling that it was never engineered to survive long term. Today I am going to show you exactly what electronics are failing inside modern washing machines, which brands have the worst documented records, and the short list of machines you can still buy that do not have a motherboard between you and clean laundry. Your grandmother's washing machine ran on a rotary electromechanical timer. No circuit board, no sensor array, no software. The timer was a physical dial that advanced through the wash cycle by rotation, switching power to the motor, the water valves, and the drain pump through direct electrical contacts. When something failed, and eventually something would, a technician replaced it. A timer motor was $25. A lid switch was $15. A pump was $40. The repair took an hour. The machine ran another 10 years. Consumer Reports tracking from that era documented average washing machine lifespans of 14 to 19 years. Then, in the mid to late 1990s, manufacturers discovered that electronics sold. A digital display justified a higher price point. Custom cycles, delay start, and eventually Wi-Fi connectivity gave the sales floor something to point at. None of those features made the machine clean clothes better. All of them added circuit boards to an appliance that had never needed one. The mechanical timer lasted 2 decades. What replaced it does not. Here is what is actually failing inside your machine right now. The main control board sits in a machine that generates steam on every hot water cycle, vibrates at high speed through every spin, and cycles from ambient temperature to operational heat and back hundreds of times per year. Solder joints crack under that thermal cycling. Capacitors absorb moisture and fail. Voltage spikes from the motor during high-speed spin damage board traces in ways that do not always trigger an immediate error code. They degrade the board incrementally until the machine stops. When the board goes, the repair is $250 to $500 for the part before labor. And if your machine is more than 3 to 4 years old, there is a meaningful chance the board version has already been superseded, meaning the replacement is either back-ordered, discontinued, or a revised version that requires a technician to confirm compatibility. A 4-year-old machine can become effectively unrepairable from a single board failure. The second failure point is the door latch on front loaders, and this one is more insidious because it looks like a mechanical problem. On older machines, the door latch was a mechanical catch, a spring-loaded pin that engaged a strike plate. On modern front loaders, it is an electronic assembly with a wax motor or solenoid that both locks the door and signals the control board that the seal is confirmed. When the electronic latch fails, the machine will not start because the board never receives the closure confirmation. The repair is $80 to $150 for the latch itself, but the failure frequently logs a fault code that requires a separate technician visit to clear with diagnostic software, turning an $80 part into a $250 service call. The third failure is the sensor array. Water level sensors, pressure sensors, dispenser drawer sensors. Components that on mechanical machines were fixed value resistors or simple float switches and are now variable electronic sensors that drift, false report, and shut the machine down on error codes that mean nothing is mechanically wrong. A water level sensor that reads slightly high causes the machine to refuse to fill. One that reads slightly low causes it to overfill and trigger a flood protection shutoff. The sensor costs $20 to $60. Identifying which sensor is at fault requires diagnostic equipment. You are paying a technician $100 to $150 to tell you which $30 part to order. Let's talk about which brands are putting the worst electronics into their machines. Samsung is the most documented case. Yale Appliance, which publishes annual service rate data based on real repair calls across the brands they sell, consistently places Samsung among the highest repair frequency brands in the washing machine category, with control board failures and electronic door latch failures cited as the primary drivers. Samsung's parts supply chain for washing machine boards has been flagged repeatedly by independent repair technicians, long lead times, frequent version revisions that make older boards non-interchangeable, and a pattern of discontinuing board support on machines as young as 4 to 5 years post-production. If the board goes and Samsung has moved on, you are done. LG presents the same pattern through a different component. Their turbo wash and wash tower lines generate consistent owner reports of inverter board failures, the board that controls the direct drive motor, with replacements running $200 to $350 before labor. LG's own response to their board failure rates was to create an extended warranty program. That program exists because LG's internal service data showed failure rates that made the standard 1-year warranty commercially huntable. The extended warranty is not a customer benefit, it is an acknowledgement. Both brands make machines that clean clothes exceptionally well by every performance metric. The problem is not the wash cycle. The problem is the electronics wrapped around it, living in an environment those electronics were never rated to survive. Before I show you what to buy instead, drop a comment right now with your washing machine brand, how old it is, and whether you have seen an error code or a repair quote yet. I want to know the real failure timeline, because the number manufacturers publish in their reliability marketing is not the number technicians are seeing in the field. Here is what does not have a board. Speed Queen's TR series, the TR5, TR6, and TR7 top loaders are built on a commercial platform with an electromechanical timer, a mechanical transmission, and no main control board in the timer-based models. There is nothing to short out, nothing to crack under thermal, cycling. No software version to become incompatible with a discontinued part. Speed Queen tests every unit to 10,400 cycles, which they document as the equivalent of 25 years of residential use. The TR7 carries a 7-year parts and labor warranty, the longest in the residential washing machine market. It starts at $1,049. There is no motherboard between you and the spin cycle. If you need a front loader, the Miele W1 series is the only machine in the category where the electronics are engineered to the same longevity standard as the mechanical components. Miele designs every machine to a 20-year service life and guarantees parts availability for 15 years after a model's discontinuation. The board in a Miele machine is not a consumer electronics component dropped into an industrial box. It is rated for the environment it lives in. You will pay $1,599 to $2,199 for that difference. Over 20 years, that is the cheaper machine. And if the budget does not reach either, the rule is simple. Buy the cheapest top loader on the floor with the fewest features. A basic $500 top loader with a mechanical timer and no digital display will outlast a $1,100 front loader with a control board by 5 to 8 years in real-world service. Boring is durable. Here is the rule. 2 sentences. Check the control panel, count the features. Every digital display, every custom cycle, every Wi-Fi connection is a circuit board living in steam and vibration. The more features on the panel, the more failure points between you and clean laundry. Manufacturers did not add electronics to washing machines because the machines needed them. They added them because features sell at higher margins and circuit boards fail on a timeline that generates a second purchase. The mechanical timer lasted 19 years. The motherboard does not, and everyone in the supply chain knew that before the first one shipped. Next week we are covering dishwashers, specifically the moment manufacturers removed the food grinder and replaced it with a filter you are supposed to clean by hand. What that decision did to cleaning performance, and why the quiet dishwasher in your kitchen is making you do the dirty work it used to handle itself.